Well, hi everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for Friday, May 24th, 2013. Joining me this week, we've got David Dickinson. Hey, David.
Hey.
We've got Dr. Matthew Francis.
Hello.
Dr. Francis. Dr. Nicole Gallucci.
Who apparently can't spell hangout. Sorry, guys.
We are hanging out.
We're hagging out.
Hagging out. It's our Weekly Space Hangout. All right.
It's pronounced Hagu, like ragu.
Oh, Hagu. I was thinking of something to do with haggis.
Hagu.
I'm going to Scotland.
Dr. Gallucci. Can you keep it together? All right. Scott Lewis.
Hi, everyone.
And we've got someone new joining us this week. So Alessandro Springman is at the Arecibo Observatory. Now, Alessandro, we need
prove it.
proof. Prove it. This is so cool.
That's a scene from Contact. Yeah.
I am invincible!
So with this happening, I'm out for the night. See you guys later.
Yeah.
I can't compete with that.
So Alessandro, you now officially win the internet. That is so awesome.
You
But
can
that
send
also
all
means-
gifts and prizes to End of Road 625, Arecibo, Puerto Rico, USA.
End of road. I love
End
it.
of road.
That's your
It
choice.
also means you win 4chan, and I don't know if you want that. So,
Ew.
sorry.
End of line.
So this week we're going to be talking about an upcoming conjunction, a mega galaxy merger, an upcoming launch from Cape Canaveral, images of the Oklahoma tornado from space, an upcoming asteroid miss, and NASA's 3D printing in space. And now you can talk to us, give us your comments, questions, feedback. We're happy to talk to you. The way you can do that, there's a bunch of places. One, if you're watching this on the event page on Google+, go ahead and make your comments there, and we should see them. If you're watching this on YouTube, you can make your comments on YouTube. And you can make your comments on Twitter. Just use the hashtag #SpaceHangout.
Yep.
Yeah. Or if you're watching this sort of on someone's stream in Google+, we should be able to catch that there. The safest place, if it feels like we're ignoring your comments, is probably over on YouTube. So if you're watching this video embedded somewhere, just click watch on YouTube, and then you can go there, and then you can share in the wonderful, lively YouTube comments. All right.
Where we can really ignore you if we have to.
We are not ignoring you. We read every comment, and we love them all. All right.
About that.
You don't know about us loving them all?
What?
Yeah. That might be the
All the
Canadian in
YouTube
you
comments?
coming out, but that's not the way it is with YouTube.
We love most of them.
YouTube
nice to us.
comments. All right, well, you know what? I'm going to go to David now, and we're going to talk about the conjunction because time is running out.
Yeah, this weekend, the last few days, I've just been able to start following Venus, Mercury, and Jupiter low to the west about 30 minutes after local sunset. Mercury just became visible. I picked it up first with binoculars this past Monday, and I've been tracking it. It should be very close to Venus, like within 2 degrees of Venus tonight. If you've never seen Mercury, this is a good time to see it because Venus will be the brightest object at about magnitude negative 1.5, I believe it is. Mercury will be fainter than that, and then Jupiter will be above those two. Now they're going to move into a little triangular grouping about within a 5-degree circle of each other. I've heard people say this is the closest grouping since 2026. It very well probably is. I haven't had a chance to research to see how true that is, but I don't disbelieve that. So.
And so I've heard that this is going to be the closest grouping since between now and 2021.
2021, somewhere in the next decade or so. That sounds about right. Like I said, I haven't sat and actually run the planetarium programs to see how true that is, but it's going to be a very tight grouping. And like I said, if you've never seen Mercury, this is a good time to try. This is one of the.
I will admit, I have never seen Mercury.
Really?
Yeah. Well, I don't have a really good view to the west, so
this is one of the best apparitions of Mercury for dusk apparitions for the northern hemisphere currently of this year. Mercury has what they call elongations, where its maximum distance as seen from the Earth from the Sun. It has about 5 to 6 elongations per year, but not all of them are equally favorable because Mercury has a very elliptical orbit. Mercury can have an elongation where it's near perihelion, so it's not quite as favorable. And the angle of the ecliptic matters as well. And right now in the summertime, the ecliptic is almost perpendicular to the horizon. So,
But I mean, you really need a nice clear view to the western horizon to really see it.
you do. Here in Florida, what we use instead of hills is I go up in the second story window of in our laundry room and actually look out. That gives me about 20 more feet, about 6 meters or so elevation, so I can actually see. We don't have hills here, so we can't actually go on a hilltop or anything like that. So
Yeah, my laundry room is on the basement, so that's not going to work for me.
helps if you got a second story floor or somewhere you can get a little more elevation around the local ground clutter. But it's getting high enough right now that you can actually track them for about 30 or 40 minutes. I was doing photographs of them last night, and I'll probably be doing it again tonight too. So I've got
mountains all the way along the west, but I'm going to be going out to the west coast in a week, and but they won't be conjuncting again. Will I still be able to see Mercury in a week?
Conjuncting.
Yeah, it'll still be visible for the next week or so with that pairing. Jupiter is going to be sliding down below the pair pretty soon. The moon in about 2 weeks will be passing the pair. The moon is full tonight, so new is in about 2 more weeks.
So are we going to be seeing Venus getting higher and higher in the evening sky now?
Yes, these evening apparitions always come from conjunction on the far side of the sun. So the evening apparitions, Venus is going to be doing a slow climb, kind of similar to what it did when it did the transit, doing the transit last year, but it's not going to transit this time when it goes in front of the sun. It's not going to transit again.
Close to Jupiter in the coming months?
Yeah, the problem is Jupiter is already lower, so we're not going to have that high pairing like we had last year.
Yeah, that was something.
It's going to be slightly lower. About every year and a half or so, we get a pairing like that where Jupiter comes back around and pairs up with Venus, and then everyone asks me, it's like, what are those two bright stars I see over the evening sky?
I've never reading Twitter I do this on purpose. I go to Twitter and I put in bright stars in a search for Twitter, and then I just follow. And people are like, how come I never noticed those two bright stars in the sky before? And I respond, because they're planets.
I always think is interesting, and it kind of shows just human perception and psychology, is how many times people will say, you should have seen how huge it looked though. And it's like, I know what they mean is they mean how bright it was. But technically to say how huge, I was like, well, it's not really Venus angular size-wise, it's not huge in visual size. But it's interesting how people will always use that reference when they see a bright object like Venus.
Those are ginormous photons, man.
Yeah. Or you get the situation where like Venus is right next to the moon, and people are like, I never noticed that really bright star beside the moon before.
And you can
the
see
moon is moving, Venus is moving. It's not even a star. Yeah.
And when Venus is very near the moon, you can see it in the daytime. I've seen Jupiter in the daytime. If you know exactly where to look for it, it is possible. But I like showing it to you.
It's a teachable moment.
I saw Sirius in the daytime once.
Yes. Yeah.
That's hard.
It is.
You got to know where to look.
You need pristine, clean, clear skies. A very high mountain blue sky helps do that kind of stuff.
My favorite is when people see the moon during the daytime and they're like, "Whoa, you can see the moon during the day." That is my favorite, because it's just being observant
it's been there the entire time. You're a little one.
It's not obvious, but it's there.
Venus is actually intrinsically brighter than the moon. Arcsecond per square arcsecond. Okay. Venus is actually brighter than the moon itself.
Wow.
And you can't see the moon when it's new in a couple of weeks, but we'll be observing it from Arecibo Observatory. We'll be hitting it with radar. And,
very cool.
Green Bank Observatory in West Virginia will be receiving the signal that bounces off the moon, as well as the LRO spacecraft in orbit around the moon. So even when you can't see the moon, people are still doing science on it.
She's one of my people, you guys. Radio. This way. Radio.
But she works in radar, not radio.
Same thing.
It's the same thing. So whenever you yell at us,
they're just the same.
Wavelength.
Those words are interchangeable.
No.
Okay.
Damn it.
All right, Fraser. High five, Fraser.
I walked right into that one. I did yell at you guys for that couple of times.
All right. We're going to move on. This time we're going to talk about a mega merger from Dr. Francis.
All right. Well, even though the prettiest galaxies out there are spiral galaxies, with those beautiful spiral arms and everything, there's a fair number of galaxies that are called elliptical galaxies, which look a lot more boring. But the thing about them is that the stars they have in them are not the young, bright bright blue stars we often see in spiral galaxies. They are on average an older population. And so the question is, when did these galaxies form? Based on analysis of the population of the stars, we know that a lot of them formed at the same time, and this time was a long time ago. So trying to figure out when these galaxies formed and how requires looking back, looking into the deep past with big telescopes. And the biggest galaxies, the biggest elliptical galaxies in particular, have provided a bit of a mystery. We haven't seen the progenitors of those galaxies, although there's a good idea that they probably were formed by mergers of smaller galaxies, because how do you make a big galaxy? You collide two smaller galaxies together, and after a while things settle down. And so that's exactly what this new observation found. Using data from the unfortunately now defunct, well, mostly defunct Herschel telescope, astronomers located two bright galaxies in the process of merging together. So let me pull up that picture while I'm talking. So what they found is that these galaxies are each individually very bright. There we go. Everybody seeing that?
Yep.
So these are individually very bright galaxies, and then when they are the process of merging means that they are undergoing accelerated star formation. So they're basically going to use up all of the raw materials required to make new stars in a relatively rapid period. So, and this collision happened roughly, well, between 10 and 11 billion years ago. So we're just getting the light from it now, but this happened a long time ago, and we're seeing back into a much earlier period in the universe's history. So if we can look back and see more of these things, then it would pretty much settle the origin of these giant elliptical galaxies, the largest galaxies we know around. So very cool, very interesting result, and you can see the picture on the right is a highly magnified version of this. So that bit is just that little tiny blur in the center of the screen. So we are talking about something that's very, very distant, very interesting.
But is there any difference between this object that's, you know, very far back in time and the kinds of like really big galactic mergers that are going to happen in the future? Like, for example, we're going to be colliding with Andromeda in the next 10 billion years. Probably going to create a big elliptical galaxy as well. Is there a difference between these ones that happened when the universe was a lot smaller, a lot more compact than these days?
Well, certainly there is a difference, simply because what we're seeing in the early days. Well, okay, let's put it this way. The galaxies that we see that are ellipticals today used up all of the raw material to make new stars a long time ago. So they shape their environment very strongly. These galaxies are common in clusters of galaxies, galaxy clusters. So it's more to do with, you know, what is the universe that we see today that look the way it does? And we know that we will probably merge with Andromeda some point in the future, and it'll probably the end result will be an elliptical galaxy. But the thing is, at the time that these galaxies were merging, there was a lot more raw material available for stars to form. So they burned through all of that gas in a period of a few 100 million years. That kind of thing won't happen when we collide with Andromeda. It's going to be, there will be new stars formed. It'll look pretty impressive if you could see it. Some bug-eyed alien astronomer looking at this whole thing happening from a distance away, they'd see something really incredible going on. But
yeah, so basically these large elliptical galaxies, it's because we know that there's this higher. You can't see me making hands.
You have to choose. Show us the picture or your cool hand gestures.
Here, I can bring my picture back up while you talk.
No, you use the hand gestures while she's talking. Imagine what she's doing. Teamwork.
And we're on air again.
Yay, we're on air again.
All right.
This is unfortunately not the first time this has happened this week.
Coming back from sharing an image.
Yes, this has happened.
Yeah, it's pretty memory intensive to share images into.
Several hangouts to different hosts. Anyway, what I was trying to get across is we have this picture of hierarchical formation of galaxies. That means from the time of the early universe, you start building small galaxies. The small galaxies come together to big galaxies. But we look back and we see these huge, massive elliptical galaxies even in the early universe, and we're still figuring out how they formed. And like Matthew was saying, because it had a lot of this gas, this was an intense period of active galaxies. So you have all this gas hitting the supermassive black hole in the center, as well as causing all this star formation. Again, like he said, when Andromeda and the Milky Way collide, it's not going to be as spectacular in that sense. But we're actually seeing this happen in the early universe. And although we've seen the end products of it, it's really important that we see this process as it's happening.
Right.
Very cool.
She put it better than I did.
Oh, no.
I heart galaxies.
She hearts galaxies. All right, so we're going to move to Alessandro and talk about a asteroid that's about to miss us, fortunately.
Okay. Well, fortunately, it's about to miss us. Alessandra is generally accepted pronunciation, but most people just call me Sandy. So
Sandy
there's a giant. Yes, there's a giant asteroid, 1998 QE2, and it's going to pass Earth by about 3.6 million miles on the end of next week. And so this is a pretty big asteroid. It's 1.7 miles across. It's a couple kilometers in size.
How many Rhode Islands is that?
I don't remember. It's less than one Rhode Island.
How many Texases is that?
Hundreds of Rhode Island.
Are we in?
It's itty bitty, but the metric, the yardstick some people have been using to measure this thing, since its provisional designation ends in QE2, is Queen Elizabeth II's, the ocean liners.
Nice.
So it's about, if you lined up 9 QE2 ocean liners end to end, it would be just as long as this asteroid is long. But this asteroid is a big chunk of rock. It would obviously be a lot bigger than 9 cruise ships stacked end to end. So it's coming really close by to Earth, but the exciting thing about this asteroid is it's really big. A lot of asteroids that come by all the time, there may be, we looked at one recently that was 5 meters across. We've looked at ones that are 100 meters across, a half a kilometer across. This one's almost 2 miles across. So it's going to be really easy to get a good look at it with radar. So most asteroids, when they come past Earth, actually all asteroids, are so small, they're so dim, that we only see them as points of light in our telescope. We can't tell really their size. But radar is a really great way to not only improve their orbits, to find out, yes, this thing is not going to come hit us, to rule out potential future collisions, but also to take images with radar. So I don't know if you've seen some radar images in the past. Emily Lakdawala has a really great post today about radar tracking of asteroids, and she's also got some images on there. But radar is really the only way we have from Earth of taking actual images of asteroids and seeing what they look like.
And so, I mean, what kind of resolution do you think we're going to be able to get?
We can get a couple. Go ahead, sorry.
Oh, I was just going to mention, like, I remember there's some great radar observations that were made of Ceres a couple of years ago, and some comets have been done. But I mean, you know, it's going to get pretty close. You can see it.
It's going to get pretty close, and it's really big. And so we can get our resolution actually doesn't have to do with how far away it is, but how quickly you can switch the transmitters that we have here at the observatory or at Goldstone Observatory in California, how quickly you can switch them back and forth. And so we can get about 7.5 meter resolution here, or about 3.5 meter resolution at JPL's Goldstone Observatory. It's pretty amazing. So you're seeing boulders, you're seeing things the size of rooms, the size of cars on the surface of these asteroids. And since this thing is large, we're going to see, is it one giant, is it spherical? Is it lumpy? About 20% of the asteroids that we see that come past Earth look like two lumps stuck together. They look like a lumpy potato. And about 15% have moons. So maybe this thing has a moon.
Tutatis looks like that, like a lumpy.
Right.
Tutatis kind of looks like a piece of clay that someone squoze, I think.
Yeah.
You know, I took ceramics in kindergarten. Reminds me exactly of that.
Actually, we hope it has a moon, right? Because that's how we can find its mass.
Having a moon is a great way to find its mass. The other way you can find its mass is if you've looked at an object for a while, if you've gotten light curves, if you've known its rotation rate. There are a couple of non-gravitational forces, actually, that we know how they'll affect an asteroid. So if you can get its model, if it's, you know its shape pretty well, and you can watch its orbit change, and you can watch its spin rate change, you can actually model these non-gravitational forces. They're called the Yarkovsky effect or the Yorp effect. And from those, if you know the shape of the asteroid, you can actually back out the mass that way. So you don't necessarily need a moon to get the mass of an asteroid.
And so what's the date that it's going to be flying by?
It's going to be coming, we start observing it here on the 30th of May. Nicole has a link that she's going to be sending out from the JPL press office. And we're looking at it for a week from Arecibo Observatory. So hopefully if everything works properly, I'll be posting about it on the Planetary Science blog. And I'll also be tweeting about it too. You can follow me on Twitter. I'm Sondy, S-O-N-D-Y.
And David, I'm assuming you're going to try and observe it.
I was going to ask, do you know what the visual magnitude is on that? I haven't seen it yet.
Don't, but it's coming in pretty close. It might be sort of dark, so it might not necessarily be a great... I think we might have time on some optical telescopes to look at it as well.
That's like about 8 lunar distances, I think, 9 lunar distances, something like that. So.
Yeah, it's coming in pretty close.
Usually below 10th magnitude is usually a little faint. I usually don't tell people to observe it unless it's going to be above 10th magnitude because it's just too faint.
Well, I'll follow up with you on that one.
All right.
And I also think this one is up at night, so it can be seen by people with normal telescopes and not just big radio ones.
All right, well, consider this a story assignment, David. If people want to know how I assign stories, that you just watched it happen.
Now, if we have another Chelyabinsk incident like the last time we had another near-Earth asteroid come by, it wasn't me.
Right.
Yeah, awesome. Well, you'll be woken up, trust me. You'll be woken
I'll call you.
Okay, so Scott, you've got some images of the Oklahoma tornado.
Right, so 4 days ago...
We don't want Nicole to share them because then we would lose her again.
Yeah, she's noisy enough, and tornadoes are loud. But 4 days ago, we had that EF5 tornado that went through Oklahoma, and it's insane. It's like I've seen tornadoes before growing up in Tornado Alley, and they're terrifying. But seeing the aftermath of these, and now we have such great technology now to be able to image these from space, and from the Goddard Flight Center Flickr account, they've shared up some images. Plus, there's an interactive map that I'm going to go to as well. But here is you can see the path of the tornado from space. So you see this enormous supercell of thunderstorms going through, and this right here is the actual path of the tornado where it touched down over in Moore County, Oklahoma. And you're seeing this is Texas. This is really you're seeing really high definition coming through here with this enormous cell of the thunderstorms. So there is we have these different satellites up there and we're trying to find different ways to understand and be able to see what's going on here. So Digital Globe worked and took their data and put it up into a Google Maps type thing that's interactive. And this is actually from NPR that they put this up. So this streak that I was just showing everyone is this right here. And we can actually get all the way down and get into where houses were and no longer are.
Oh. Wow. Look at that.
And one thing that they're using this for, which is great, I used to work EMS and fire, and being able to see where things were, having this ability to know the infrastructure of a place after, before and after a really bad incident like this, allows you to get a scope of what we need to be doing as far as reaction, and where we need to, we are able to get this. This is 4 days. Typically, we think of going Google Earth. We don't know how long ago that's been. This is 4 days ago that this all happened, and you can zoom in there really well and see just the onslaught of.
What a nightmare! That's an amazing resource that you found, Scott. That's incredible.
Well, this was Nancy. I love Nancy Atkinson from Universe Today, but you're seeing here. There's the freeway.
Yeah.
and just watching the path. You can see the Earth, the change in the Earth itself from the powerful winds that are going on as it's just dragging across this county. So, a lot of our satellite imaging,
There you go.
Oh, so it's clearly screen sharing is like the mark of death.
Oh, wow.
I thought it was amazing when you saw footage of the tornado they were filming from a helicopter. You could see the transformers blowing out there. Those big flashes of light were all transformers.
But I mean, do you remember, like, in the olden days, like 10 years ago or so, where, there were very rare images of these really powerful tornadoes, and you would see like a couple, they would get used over and over again in various tornado chasing documentaries. But this time around, everybody's got their smartphone, everybody's got a camera all the time. There's so much footage. It's kind of like back to the Chelyabinsk meteor, because we had all these Russian road cameras that were capturing this. We never would have had that 10 years ago, and now suddenly there's all of these cameras out there in the wild.
Yeah, and we have all this technology now that I get really frustrated when people say, "Oh, why are we sending stuff up to space? That's not really practical to what's going on here." This is a perfect example of why we need to continue developing these technologies and ways of imaging not only outside of our planet, but being able to turn it around and see what's going on here. From a purely from my previous career, if I had this data for some of the mass casualty incidents I've run on, this would have been priceless.
Yeah.
And we have this ability to be able to deploy, rescue, and be able to find the best places to set up safe zones and just all sorts of resources. So, having this technology and be able to continue to develop this as a species, saying, hey, we need to continue to know what's going on out there, and we'll be able to help ourselves out in the process of gaining more understanding.
Yeah. Yeah, I mean, just to be able to see within days of this event happening, high-resolution photographs showing from space of the trail of the tornado is just amazing.
Yeah.
That's one of the most powerful sort of space sets of images I think I've ever seen. Just amazing. Man, I really sort of hope the people from Oklahoma are able to recover and get back on their feet. It's pretty devastating. It was a pretty awful tragedy.
And thinking about it is something that actually has been on my mind a lot lately, is that people think of space satellites as something abstract, obscure, nothing that interacts with their daily lives. And you can see the homes yourself. You don't have to wait for the news to come on. You can actually go onto your computer and see firsthand how this has affected other people. It's something that I believe has really allowed humanity to connect with one another from across the world, and we have this ability now to see the aftermath and what's going on. Yeah. And that's insanely powerful, not just technology-wise, but in a human perspective. That's insanely powerful.
So we've got a couple of questions and comments back on the asteroid that Sandy mentioned. So first, now you actually posted back on Twitter that the magnitude is going to get to 11 on June 1st, right?
Yes. But it's probably going to be, I looked for like a couple places in California. I think it's going to be much more in the southern hemisphere. So you're gonna have to be a little more better located. If you know how to use the JPL Horizons interface to look for asteroids, you can use that. If you don't know how to, tweet me with your location, and I can look up where you are and say whether or not you'll be able to look at this asteroid. But it's going to be really bright. So if you have a small telescope, you'll probably be able to see it if you're in the right location.
And Michael Jobin asks, if NASA could capture a small asteroid, could they give it a safe re-entry for a close study? So when he says safe re-entry, would there be any way you could re-enter a mile-long asteroid in a way that wouldn't cause a lot of destruction?
Or burn up at the outer surface so you've already changed the asteroid itself.
Well, so, I mean, that thing comes crashing into Earth. If you bring a mile-long asteroid to Earth and it comes in with any sort of velocity, it's going to create a 10-mile wide crater.
Yeah. And
then there was also a very interesting thing that even if you had a mile-long metal asteroid or metal sphere on the surface of the Earth, it would be so massive that it would crack the Earth's crust and descend towards the core. And a couple of geophysicists have decided this is the best idea ever for looking at what the Earth is made of, and you could put something inside of it that would thump, and it would transmit information back to the Earth's surface by seismic thumping. So even if you did bring back a 1 mile wide asteroid to the Earth, it would crack the crust. And
So make this a mile long, and hurl it at the Earth, and see what happens.
The dish in my
Make it
backyard is 1,000
smaller.
feet.
Put it in a capsule.
Yeah.
just
it's
chip off chunks.
it's an okay idea. Maybe not your best idea, Michael. Maybe try something else.
Well, you know, they
just
could
leave it in orbit.
chip off chunks,
Park it around the
right?
moon.
Park it around the
You
moon, but
could
it would be
chip
so
off
convenient,
chunks
so
of it.
easy to
Yeah.
access it as it was
Yeah.
sinking down into the core. You could like try and mine it a little as it
It's like you're
disappears.
steeping a tea bag. You know, you're like, oh, well, let's just see what's going on as
Yeah.
it's heating up.
If you had a 1 mile sized asteroid on the surface of the Earth, you'd have some other problems aside from should we mine it. But
Right.
I mean,
wouldn't
so
there
if
be
you
this
had
sort
a
of global destruction from the impact and the sort of the winter that would happen for the next couple of decades?
Crazy
The loss
why
of
you're not in
lots
charge
of
of
vegetation
things.
on Earth and
you'd have 99 problems, and studying it probably would not be one.
right.
But with a smaller asteroid, back when the space shuttle was actually in service, there was talk about, you could take a small asteroid, you could, lasso it, put it on a leash, bring it back, put it in the space shuttle cargo bay, and bring it back to Earth. But it'd have to be pretty small because, as we all know, metal is really dense. So if it was a stony asteroid, it would still weigh a lot. But you could at least start thinking about bringing something a little smaller home. This is why NASA is talking about bringing home a pet rock on a leash, putting it in orbit near the Earth, and having astronauts go visit it, because it's a little easier than getting it to the surface of the Earth.
Oh, I missed
Leave
that
it up
one.
in space so we can
Who's a good
rely on it,
asteroid?
access
Who's a good asteroid?
that asteroid.
Our
Yeah.
80s are showing. It's
Yeah.
kind of nice.
Pet rock, yes.
Even like
Expanded.
dropping it into the ocean would be even worse.
Yeah.
Yes,
Then
and
you
even
Think
if
you're gonna
it's-
park it in the ocean? That's not gonna help.
So if we put this out in space, can we put big googly eyes on it? I think we totally should.
Vandalize!
I'm not in my office right now, but my light switch has googly eyes on it, and I'm
All right, I'm gonna move on to another story now. I have decided.
I think we needed that laughter after the previous one. So.
Yeah. So David, this is a really cool story that you worked on, which is NASA's working on a 3D printer for pizza, for food.
Yeah, there was actually NASA just awarded a contract earlier this week, $125 contract company to research a 3D printer that would print pizza in space. That would actually go to the ISS and be able to print layers on
Yeah, you had some latency issues, David.
Yeah, we can't hear a word you're saying. Well, we can hear the words you're saying, but they're
We hear every other
Computerizing.
syllable.
How about now?
good. Don't move.
Yeah, okay. It's NASA awarded a $125 million contract earlier this week for a company to design a 3D printer that they're looking at actually printing a pizza layer by layer of having the dough and then have the injector do the tomato sauce and then do what they were talking about is putting the protein layer on the top. Now, what was interesting is the protein layer, the matrix they were talking about using was algae, seaweed, and insect protein. So I don't know how yummy this type of pizza is going to be. But it kind of gets to the whole idea of what, if they're going to go on longer-term missions to Mars, what they're actually going to be able to eat in space.
They're going to be craving their insect pizza.
Well,
So that's taking tofurkey to another level.
and the first thing I wasn't entirely clear on, when the first thing I thought when I read this, I was like, how are you going to 3D print a pizza in 0G without having tomato sauce flying around in globules and things like that? There actually have been, because they are flying a 3D printer at the International Space Station next year. There's a company called Made in Space that is doing 747, the equivalent of the Vomit Comet type flights, and they are doing micro-G experiments with 3D printers that they are going to ship up there. This one isn't scheduled to print food. It's going to be more as kind of a proof of concept of print like basic parts and things like that on site on the International Space Station. But you may see these more. What I think is interesting is RipRap, the company called RipRap, actually has a 3D printer that can print itself. It can print the parts. necessary. So
The singularity is about to happen.
so the von Neumann
Self-replicating.
machines, the von Neumann machines are just about here.
Send in the berserkers.
Well, it can print part of itself. It can't. I don't think one
can't
can
assemble
print its
itself.
whole
Yeah.
self. Yeah.
Don't give it
not
any
yet.
way to plug itself in. That's it. If long as
Next
it
month, Cybermen.
plug itself in, then we're fine.
That's about a decade away. So.
I'm hearing like a
Vacuum cleaner.
yeah. Right. So now you said 125 million. Is that right? 125 million?
Oh, 125,000.
Ah, yeah. Okay, that's a different number.
Yeah.
One would have people rioting in the streets and petitioning their congressman, and the other one would be like, who wouldn't want some bug pizza?
125,000 for a 6-month grant, and the company is Systems and Materials Research Corporation that's designing it.
And NASA's actually been working on this kind of stuff. They've been working on artificial meat as well. Printing meat and but you can really see.
Did you hear about that $250,000 hamburger?
Right.
Did you hear about that? Yeah, I mean,
no.
They're growing beef.
One thing they know from Biosphere 2, from the experiment there, is they're not going to be able to raise animals on a trip to Mars. They're not going to be able to have chickens or cows or anything like that. So your basic source of protein might be what they call micro-enriching. It might be insects.
Bugs. It's bugs.
Algae, kale, or not kale, but just basic, protein, plankton.
Kale is a plant.
Yes,
Bug Girl.
The reason
I'd be glad to tell us all about how delicious bugs are.
The reason I had kale on the brain is Elon Musk recently tweeted to PETA saying that he would not be the Kale King of Mars. When he was talking about Martians colonists might be vegetarians, PETA had tweeted back to him and says, well, don't you mean that they would be vegan? So it's like that discussion's kind of already out there of what kind of diets would a Mars One type mission.
Right.
We would eat Martians.
I will eat kale on Mars.
Me too.
I would eat kale.
I would eat kale on Earth.
I would eat kale to go to Mars.
I'd eat kale today.
I grow kale.
Yeah.
Delicious.
Guys! But this means we're gonna have replicators soon. And we're gonna be more like Star Trek.
That's it. That's what matters. Is that
That's
we're
what's
going to have
exciting.
replicators.
And I can ask for tea, Earl Grey, hot, and
It'd
And
be
they'll
interesting
just show up.
It'd be interesting to see if we have food replicators in our kitchens in a decade or so.
Yeah.
If the human element is going to take to the technology or not.
right.
All the Star Trek fans will.
Well, have you seen? There's a guy on the internet, which this can't end well, is making a thing called Soylent. Have you seen about this? He's like,
Yes. Yes.
Hey,
I
he's
worked
like-
that into the article.
yeah. Did you work that into the article?
I worked the reference to Soylent Green.
Oh, okay.
Is it people?
He
Please
got
tell me
the
it's people.
reference too, but the gist is he's like trying to boil down human nutrition down into the absolute raw essentials. And his
Literally humans? He's boiling down.
no humans in it. Human nutrition, the requirements for human survival,
Okay.
and it's got like, I don't know, the right amount of carbohydrate and protein and fat and the various essential nutrients and micronutrients and so on. And he's just made this drink that he drinks, and
But does it taste like chocolate?
he
It
seems to
tastes
love
like
it.
Chocolate.
He seems to crave it, and
I'm sure he
but-
craves it once you have human.
Of course you crave it. Yes, I know. And that's how Soylent Green happens.
Well, the company that's designing this 3D printer is hoping it will take off commercially as well. So I don't know if we'll be printing Domino's pizza pretty soon. It'll probably take more than 30 minutes, so I don't know if it'd really be worth to print a pizza at home.
You won't have to tip it though.
I should invest in some kind of a bug farm right now, because that's going to
Well,
be
the 17-year cicadas are hitting the East Coast. There's plenty of
There you go.
harvest.
right.
There you go.
Right.
There's a lot of
Some kind of
protein
cicada
going on
farm where every couple of years your bugs come out and then you stick them into the replicator. Right. But is that really what it is? When you think about, like, when Captain Picard is asking for, I don't know,
They put matter in it, and
Gray
matter
hot,
comes
what he's
out.
really getting is just bugs.
What's the matter with that?
Yeah, love it.
Most processed foods already have a few. There is an acceptable limit of how many bug parts are in, like, peanut butter and things like
Right.
that.
Yes.
We're probably already eating bugs.
Yeah. No, of course.
We are. Yeah, it's not probable. This is how much.
Do you ride a bike? If you ride a bike, you eat bugs.
Yeah.
Oh my god, we need Bug Girl in this episode so
There
badly.
you go.
Yeah, totally. All right, Dr. Francis, please tell us about a new measurement to SS Cygni.
Okay, well, there's a certain type of binary system known as a recurrent nova. You think of a supernova as something, big explosion that you can see halfway across the universe, literally in some cases. But there's also smaller things that don't actually destroy the system, and one type is a recurrent nova. SS Cygni is one that's not too far from the solar system. It consists of a red dwarf, which is a star smaller than the sun, and a white dwarf, which is, the remnants of a star like our sun. According to theory, the white dwarf strips gas off of the red dwarf, falls onto the white dwarf, but the temperature is low enough that, okay, stars are plasma, but the temperature is low enough that the electrons can rejoin with the atoms, and that creates a big outburst of energy. So that's what causes this recurrent nova. The problem is, in 1999, astronomers using the Hubble Space Telescope measured a distance to this system called SS Cygni, and found that it was too far away. In other words, it appeared to be hotter than would be expected from that theoretical model I described. It's too hot for the electrons to join with the protons. So that was a problem, because that led people to wonder, okay, do we have the model wrong? That's a big issue. So another group of astronomers using the Very Long Baseline Array, VLBA, got to say that for Nicole's sake, radio astronomy, and then the European Very Long Baseline Interferometry Network, EVN. That's a mouthful.
That one's a nested acronym.
Yes,
so.
it's a recursive. I guess not a recursive. But yes, it is a nested acronym. Nested. But it was what they did is they did a new measurement. The nice thing about a system like SS Cygni is, unlike an ordinary star, it's pretty bright in radio light. And I didn't know any of this, by the way. I'm a cosmologist. I'm not an astronomer type dude. So it turns out that you can actually get a little more accurate distance measurement using radio telescopes if you've got a good radio source, because you can calibrate the distance using an extragalactic source. Whereas if you're using visible light, you have to kind of take an average over positions of nearby stars. And so what they found is this revised distance measurement using radio telescopes brought it well within the range of what would be reasonable for this theoretical model. Of course, now we're left with the mystery of why the visible light Hubble Space Telescope estimate was so different. So assuming the radio measurement is more accurate, which my untutored opinion seems like it's pretty accurate. They seem to have done a pretty thorough job. Why the Hubble measurement is so far off. So we have not heard the last of SS Cygni, I think.
But these, I mean, if I understand correctly, right? These are, you've got like a white dwarf star, and you've got another larger object and the white dwarf is siphoning material off the larger star, right? And as the material builds up on the white dwarf, it gets to a certain point, and then it flares off, and you see these nova eruptions. But I mean, isn't that also sort of how a type 1a supernova is formed, where you get a white dwarf that gets to a point that it, passes the limit, the 1.4 times the mass of the sun, and then...
Yeah, that's going to be true if the white dwarf is near that mass limit to begin with. But most white dwarfs are not quite that big. So, in fact,
in this case, it's helium fusion that sets off the nova.
Yeah, well, that would be
it's not reaching the mass limit. It's the fusion.
Right. Okay.
Runaway fusion.
No, it's recombination in this case.
Okay.
SS Cygni is electrons rejoining the protons.
Oh.
There is another type of of nova that is helium fusion on the surface of the white dwarf. And that's a system where it's very hot. This is okay, it's funny to talk about it being this being cold, but it's it's all relatively speaking here. But it's a much colder system, too cold for fusion to happen. And so the outbursts are when the temperature gets too low instead of too high. So this is a much gentler system than anything that we'd be comparing to a Type 1a supernova.
So gentle.
Yeah, relatively speaking.
Relatively speaking, too, one of the most powerful explosions in the universe. Yeah,
well, it's not like this is. It's not like this is. I mean, the thing too that's kind of cool about this story is that the astronomers recruited a group of amateur astronomers to help them monitor this as part of a citizen science project. So they kept an eye on the SS Cygni system. When the flare began, they would ping the radio astronomers, who would then trigger these vast networks of radio telescopes to try to get a handle on their location, so on the distance to the system. So it was a pretty cool thing, pretty cool project.
All right, so one last story, a quick one here. Now, David, you put this on the docket. I'm not sure. So there's not going to be an eclipse?
There is an eclipse, and no one's going to see it. There is a penumbral eclipse in a few hours.
There's always an eclipse that no one sees.
Well, it's a penumbral eclipse when the moon goes through the outer part of the Earth's shadow, which is very bright. If you ever watch a penumbral eclipse, they are very subtle. And this one is the first one on this Saros cycle. So it's going to be only about 2% inside of the Earth's outer shadow. So it's going to be too subtle to see right about, it's midnight about East Coast time here. It only lasts for about 20 minutes. But it was interesting to write about because this one actually starts a new Saros cycle, Saros being a period of 18 years, 11 days, and 6 hours where eclipses follow the same series of patterns. And it lasts for about 1,200 years, each Saros cycle.
Wow. So when do we get to see an awesome lunar eclipse?
Not until tax day, American tax day next year, we get a total lunar eclipse, different Saros. There's about 41 Saroses active right now.
That's
So
April
different
14th, 15th, right?
15th, yes.
Yeah.
There's one North and South America we'll see. There are 2 more lunar eclipses. This year's a bad year for eclipses, actually.
It's been a bad couple of years, yeah.
There are 2 more lunar eclipses on the next. There's 1 more lunar eclipse actually on the next lunar eclipse season at the end of this year, but it's going to be another penumbral. The only thing interesting you can do during a penumbral, if it's a deep penumbral, is I've taken photos of the full moon before it goes into eclipse, during eclipse, and after. If you can compare them, you do see a little bit. The moon looks like a light brown instead of white when it's in a penumbral eclipse. But
you're still not making it interesting enough, I think.
It's not. It's probably the ultimate non-eclipse. And this one is going to be so shallow that it's not going to be noticeable. But it is interesting that we're starting a new Saros cycle.
But we will, I'm sure, be doing live coverage of the one next year. It'll be amazing. I love it.
Interestingly enough,
stories about how the IRS is blocking out the moon. So we have the supermoon stuff we have to deal with, plus we're going to have to...
Right. Oh, is it time to debunk supermoons? David, could you write a bunch of debunking supermoon articles, please?
I'll recycle my supermoon.
Yeah,
everything in my brain.
Just bring it back up again.
Apparently, we were just talking about before we started the show. It's starting to be like the Mars hoax, where almost every full moon is a supermoon, and it's astronomers dislike the term, but of course we all write about it because it gets high SEO hits. About it. So
it's a cool term, and it is cool. I mean, when the moon is at its closest point, it is visibly larger in the sky and much brighter. This is a real thing. It is a supermoon.
And it has a cape and tights, which is why it's called the supermoon.
It's got soul and it's supermoon.
Yeah,
I prefer perigee or proxygean moon, but no, apparently proxygean moon's just fallen off.
We're going with supermoon.
Nobody says proxygean anymore. So.
And it's a teachable moment, David. Every time a person shows up going, I wonder how the supermoon is going to affect my behavior, we say it's not, and then we explain why. And then
you can talk about the moon illusion, how the moon looks bigger on the horizon, but it's actually the same size. Well, actually, we're going to have a series of them because this moon tonight is fairly close. The close one is June full moon, and then the July one's going to be fairly close too. But the moon comes just about almost as close every lunation. So
Fantastic. That's great. All right. Well, I think we're out of time, so why don't we start wrapping things up? So we're going to let our newbie give us some more information. So, Sandy, where do people find out more about you? Apart from the address that you gave, which is at the end of the road in Arecibo, which I'm not sure that sounds legit, but yeah, where do we find out more?
It's that's what you give to UPS and FedEx. It works great. So you can go to the JPL website. They have a fantastic press office there. We're sort of a bare bones operation. The NSF has been threatening to cut us off for a long time, so we don't have nice things like a press office or a press person.
Yes.
I'm on Twitter. I will be posting all sorts of links and retweeting things. Emily Lakdawala of the Planetary Society is a great resource. So if you go to planetary.org, there's a lot there. And I might even link to something from my own website, which is really easy. It's sandy.com. And you can find out more there. And space.com.
You've been iterating for a long time, haven't you? You've got the early Twitter, you got a good domain name.
She's got a good name for it.
Yeah.
Break out.
All the Nicoles were gone, but
I
Sandy's
know.
not
You couldn't
gone.
get Nicole.com.
I think I got sandy.com 99, 2000.
Yeah.
Back when you could register domain names for free.
Those were the days.
Yeah, so if follow me on Twitter, there's a bunch of other resources for finding out about these asteroids, and we try to find them before they find you. And thank you. Your tax dollars at work. Thank you.
And
Those
thank you very much
predators.
for joining us. And thank you for giving us that amazing view of the Arecibo Observatory.
Well, we can do it once more.
Yeah.
Yay.
It's just started raining a couple of minutes ago.
Oh, we heard thunder, yeah.
Wow.
Yay!
Fantastic. All right, David, where do we find out more of David Dickinson? He's
I
muted.
am tweeting and blogging on astronaut.com. I'm on Twitter today.
He's at garble.
Garble, garble. I'll do this for him. You can see more David Dickinson. He writes it. He's Astro Guys on Twitter, and he also writes a whole bunch for Universe Today.
There you go.
Yeah. So don't listen to his computer simulation.
Exactly what he said.
Dr. Matthew Francis,
You
a.k.a.
can,
the Bowler Hat Science.
yes, find me at bowlerhatscience.org, galileospendulum.org, that's my science blog. Twitter at Dr. M.R. Francis. That's
Dr.
not
Mister?
Dr. Mister.
Dr. Mister.
Not Dr. Mister.
That's how I read it.
You're going to start me
declared it so.
singing Mr. Mister songs again. And then various other places, Ars Technica, BBC Future, New Yorker blog.
All right, Dr. Nicole Gallucci.
Hi, Noisy Astronomer. I live at CosmoQuest. You can find me at cosmoquest.org, at noisyastronomer.com, at I blog for Discovery News occasionally, all over the interwebs.
You've escaped Universe Today's grasp so far.
That's because every time you start to say you should write, and then you go, wait, then paddle.
No, wait, no, you shouldn't. That's right, you
No,
shouldn't.
You're already doing too much of
No,
paddle.
you're busy. You're busy. You're busy. Yeah, all right. Cool. All right, Scott Lewis.
Yes, I am on Twitter at ballastronomer. My website is knowthecosmos.com. I'm all over Google+, Virtual Star Party, which is every Sunday night with my co-host Fraser Kane. And we now have that also on Twitter and Facebook as well. It's _VSP on Twitter and facebook.com/Virtual Star Party, where we hook up telescopes to a Google+ Hangout and share the view of the universe through them.
I've heard of it.
Awesome. Yeah.
Yeah.
So that'll be the Sunday
Sometime
nights
in
when
Florida.
on the West Coast. So I think we're about 9 o'clock Pacific Standard Time now. So,
Yeah.
and of course, I am
Sorry, East Coast.
at Universe Today. Although you mostly don't see my writing there on Universe Today anymore. So
Because you have minions.
I've been doing videos on YouTube, and I'm doing a lot of stuff. Yeah, virtual star parties and stuff. So, but you can see my invisible hands pulling the strings behind everything that's going on. So. All right.
That sounds so evil. From Vancouver Island, Fraser Kane. Dance, puppets, dance.
Okay, well, thanks everybody for watching this week. Really appreciate it, and we will see you on Sunday night for the Virtual Star Party. Thanks for everybody who joined the panel this week. It was great, and we'll see you all next week. YouTube
nice to us.
comments. All right, well, you know what? I'm going to go to David now, and we're going to talk about the conjunction because time is running out.
Yeah, this weekend, the last few days, I've just been able to start following Venus, Mercury, and Jupiter low to the west about 30 minutes after local sunset. Mercury just became visible. I picked it up first with binoculars this past Monday, and I've been tracking it. It should be very close to Venus, like within 2 degrees of Venus tonight. If you've never seen Mercury, this is a good time to see it because Venus will be the brightest object at about magnitude negative 1.5, I believe it is. Mercury will be fainter than that, and then Jupiter will be above those two. Now they're going to move into a little triangular grouping about within a 5-degree circle of each other. I've heard people say this is the closest grouping since 2026. It very well probably is. I haven't had a chance to research to see how true that is, but I don't disbelieve that. So.
And so I've heard that this is going to be the closest grouping since from between now and 2021.
2021, somewhere in the next decade or so. That sounds about right. Like I said, I haven't sat and actually run the planetarium programs to see how true that is, but it's going to be a very tight grouping. And like I said, if you've never seen Mercury, this is a good time to try. This is one of the.
I will admit, I have never seen Mercury. Well, hi everyone. My name is Fraser Kane. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, May 24th, 2013. Joining me this week, we've got David Dickinson. Hey, David.
Hey.
We've got Dr. Matthew Francis.
Hello?
Dr. Francis. Dr. Nicole Gallucci.
Who apparently can't spell hangout. Sorry, guys.
We are hanging out.
We're hagging out.
Hagging out. It's our weekly space hangout. All right.
It's pronounced Hagu, like ragu.
Oh, Hagu. I was thinking of something to do with haggis.
Hagu.
I'm going to Scotland.
Dr. Gallucci. Can you keep it together? All right. Scott Lewis.
Hi, everyone.
And we've got someone new joining us this week. So Alessandro Springman is at the Arecibo Observatory. Now, Alessandro, we need
prove it.
proof. Prove it. This is so cool.
That's a scene from Contact.
Yeah.
I am invincible!
So with this happening, I'm out for the night. See you guys later.
Yeah.
I can't compete with that.
So Alessandro, you now officially win the internet. That is so awesome.
You
But
can
that
send
also
all
means-
gifts and prizes to End of Road 625, Arecibo, Puerto Rico, USA.
End of road. I love
End
it.
of road.
That's your
That also means you win 4chan.
We've got mountains all the way along the west, but I'm going to be going out to the west coast in a week, and but they won't be conjuncting again. Will I still be able to see Mercury in a week?
Conjuncting.
Yeah, it'll still be visible for the next week or so with that pairing. Jupiter's going to be sliding down below the pair pretty soon. The moon in about 2 weeks will be passing the pair. The moon is full tonight, so new is in about 2 more weeks. It'll
So
slide
are we
by.
going to be seeing Venus getting higher and higher in the evening
Yes.
sky now?
Yes, these evening apparitions always come from conjunction on the far side of the sun. So the evening apparitions, Venus is going to be doing a slow climb, kind of similar to what it did when it did the transit, doing the transit last year, but it's not going to transit this time when it goes in front of the sun. It's not
And
going
is
to
it going to
transit
get
again.
close to Jupiter in the coming months?
Yeah, the problem is Jupiter is already lower, so we're not going to have that high pairing like we had last year.
Yeah, that was
It's gonna
something.
It's going to be slightly lower. About every year and a half or so, we get a pairing like that where Jupiter comes back around and pairs up with Venus. And then everyone asks me, it's like, what are those two bright stars I see
Bright
over
stars.
the evening
I've
sky?
never reading Twitter when this is. I do this on purpose. I go to Twitter and I put in bright stars in a search for Twitter, and then I just follow. And people are like, "Huh? How come I never noticed those two bright stars in the sky before?" And I respond because they're planets.
And I don't know if you want that, so
Ooh.
sorry.
End of line.
So this week we're going to be talking about an upcoming conjunction, a mega galaxy merger, an upcoming launch from Cape Canaveral, images of the Oklahoma tornado from space, an upcoming asteroid miss, and NASA's 3D printing in space. And now you can talk to us, give us your comments, questions, feedback. We're happy to talk to you. The way you can do that, there's a bunch of places. One, if you're watching this on the event page on Google+, go ahead and make your comments there, and we should see them. If you're watching this on YouTube, you can make your comments on the YouTube. And you can make your comments on Twitter. Just use the hashtag Space Hangout.
Yep.
Yeah. Or if you're watching this sort of on someone's stream in Google+, we should be able to catch that there. The safest place, if it feels like we're ignoring your comments, is probably over on YouTube. So if you're watching this video embedded somewhere, just click watch on YouTube, and then you can go there, and then you can share in the wonderful, lively YouTube comments. All right.
Where we can really ignore you if we have to.
We are not ignoring you. We read every comment, and we love them all. All right.
About that.
You don't know about us loving them all?
What? Yeah. That might be the
All the
Canadian in
YouTube
you
comments?
coming out, but that's not the way it is with YouTube.
We love most of them.
Really?
Really?
Yeah. Well, I don't have a really good view to the west, so
This is one of the best apparitions of Mercury for dusk apparitions for the northern hemisphere currently too of this year. Mercury has what they call elongations, where its maximum distance as seen from the Earth from the Sun. It has about 5 to 6 elongations per year, but not all of them are equally favorable because Mercury has a very elliptical orbit. Mercury can have an elongation where it's near perihelion, so it's not quite as favorable. And the angle of the ecliptic matters as well. And right now in the summertime, the ecliptic is almost perpendicular to the horizon. So,
but I mean, you really need a nice, clear view to the western horizon to really see it.
You do. Here in Florida, what we use instead of hills is I go up in the second-story window of in our laundry room and actually look out. That gives me about 20 more feet, about 6 meters or so elevation, so I can actually see. We don't have hills here, so we can't actually go on a hilltop or anything like that. So.
Yeah, my laundry room is on the basement, so that's not going to work for me.
Helps if you got a second-story floor or somewhere you can get a little more elevation around the local ground clutter. But it's getting high enough right now that you can actually track them for about 30 or 40 minutes. I was doing photographs of them last night, and I'll probably be doing it again tonight too. So I found